Hello, my name is Nishant Rathore, and I'm going to be talking about my course project, Solving Blackjack using Reinforcement Learning, that was supervised by Dr. David Churchill. What is Blackjack? Blackjack, also known as 21, is a popular card game played by millions of people at casinos around the world. Blackjack is arguably the most widely played game at casinos. There are several different versions of Blackjack exist, and all the different versions available online for play. Blackjack tournaments, including World Series of Blackjack, Las Vegas $1 million tournament, and several other world championships, have been organized regularly, and they regularly award winners high prizes in millions of dollars. What are some of the main goals of Blackjack? The main goal of in blackjack is for the player to get their hand as close to 21 as possible. But the caveat is they cannot go over 21. If they go over 21, they will lose the game. The game is always played between a player and a dealer using one or more card decks. Now there can be more than one player in the game, but each player will be competing against one dealer. Once the player gets dealt their card and the dealer gets dealt their cards, the two hands are compared and the bigger hand wins the round as long as the winning hand is less than 21. These are the card values in the game of blackjack. Cards ranging from 2 to 9 have the same value as return on their card. An ace can be considered as either 1 or 11, depending on which is better for the hand. Jack, queen, a king, and a 10, they all have a numerical value of 10. What are some of the basic rules of blackjack? And there are way more than rules available that are have listed here, but some of these are some of the basic ones. A hand in blackjack is the sum of numerical value of each card in either the player's or dealer's possession. If my hand has a 10 and a 2, then my hand has basically has a value of 12. If the player's hand or dealer's hand is over 21, it is considered as bust. That means they have lost the game. If a hand consists of an ace and a 10-point card, could be either queen or a king, etc., then it is called a blackjack or a natural. If the dealer busts, then all the remaining players' hands win. If the player has a natural and the dealer has a natural, then the game will end in a draw. If the player has a natural but the dealer does not, then the game will be decided because the player has a natural already, so that means they have won the game. A blackjack hand always has a higher priority over any other hand, even if the other hand has a sum of 21. If the dealer's hand is lower than 17, then the dealer will always take a card from the deck. But if they have their hand is over 17, then they cannot take another card. These are some of the game decisions that a player can make during a game. A hit is an action taken by the player asking for one or more card that can be added to their hand. A stand, that is the action taken by the player signaling other players and the dealer that they do not want to take any other card. A double down, a player can take a risk here and double their bet in the middle of their hand, but the problem is they cannot take more than one card from the deck afterwards. A split, a player can choose to split a hand into two different hands only if their initial hand consists of two cards of the same value. But their second bet has to be of the same value as their original bet. Now we're talking about Blackjack because we want to solve the game of Blackjack using reinforcement learning. And Blackjack, is, relatively speaking to other games, is very easy to simulate because Blackjack has finite number of states that can be easily represented in a form table. The actions are fixed. You either hit or stand. One can train their agent to play thousands of games to learn the optimal strategy. Now, what is reinforcement learning? And this is what reinforcement learning in a nutshell, where you have an agent that is taking an action in either a real world environment or a simulated environment, getting a reward from the environment, find itself into a new state, then take a new action or the same action, reaches into this different state, and this whole process continues until the agent has reached its goal or the simulation has ended. As you can see in this graphic, that this agent is trying to go over this blockade and gets a reward of +1 whenever it is successful. Otherwise, if it gets collided to the blockade, it gets a reward of -infinity and the game is ended. The agent can learn through its experience of playing thousands of games or millions of games and learn the optimal strategy. That is the main goal of reinforcement learning. These are some of the terminologies that we're going to be talking about in our method that we have used to solve Blackjack. A state is represented as a 2D array of player hand and a dealer hand. An action can be either hit or stand. The environment that we are simulating a Blackjack holds Monte Carlo decision property. And what that is, the next state and the future reward can be estimated only from the knowledge given from the current state and the current action. You do not need anything else to estimate the future reward and the next state. The return is the sum of rewards earned from that state and taking some action. The action value function is a mapping from state action to returns. A policy is always given in with respect to the player, which is a mapping from state to actions. The algorithm that we have used to solve Blackjack is called Monte Carlo exploring starts. In this algorithm, we initialize our states and actions to some random value, and we also arbitrarily assign our state value and action value function QSA to some for each possible state and action pair to some value, and pi of s, which is a policy for the player, to some arbitrary value, and the return that's going to be storing the accumulated rewards average for a particular state action pair. And I'm going to be defaulting that value to 0. And I'm going to repeat forever. Or actually, that is not repeat forever. That is only run for X number of iterations. And I will generate an episode using exporting starts and policy and following the policy pi. The episode is actually a round of Blackjack where you would get a reward at the end of the episode. In Blackjack, you would always get the reward at the end of the episode. And you have a starting state which is generated randomly using equal probability, and you have a starting state and you follow the you take the action after following the policy pi, and then you generate a successive state using the policy pi. Now, for every action and state appearing in the episode, I would take the reward for that state action pair, and in an episode of Blackjack, each state action pair would have the same reward, and then I would take the reward and then append that to my list for that state and action pair, and take the average and store that in my queue of SA. This queue of SA, for each state, I will have two different queue values for two different actions, either hit or stand. I would take whichever is whichever action that has given me the higher queue value, and I would store that action for my pi of S. And this whole process continues until the X number of iterations. And for Blackjack, any number of iterations between 500,000 to 1,000,000 would give me the optimal policy pi of S. If you implement this correctly, you would get something policy that would look something like on the left, and the state value function that tells me how good my state is, what are my chances to win from that state for a player, that is shown on the right. Usable A's means that the A's can be counted as either 1 or 11, and no usable A's, that means the A's is only counted as 1. The method was implemented using C++. We use SFML to draw the UI, and win had a reward of +1 and lose had a reward of -1, and the return was calculated by taking an average of total rewards. We use two different averaging techniques to update our Q value. One was simply taking the each reward that we have received and taking the average of it and store that in my Q value. And the other one was the alpha method, where we have defined our the alpha to some value, either 0.1 or 0.01, and we have compared the performance of the two methods, and we got different results. Now, this is a sample output that was given by a program, and now I'm gonna run my program. I'm gonna show you how we are updating our policy. As you can see on the left side, we are showing our policy for every state. That is for the dealer and for the player. I am updating my policy after running running different iterations for that method. And you can see that H of S, there are some cells that are blinking H of S. That just tells me that that cell has is on the fence between hit and stick. On the right side, I have two values that is displayed for every cell. The first one on the top is for the Q value for the action stand, and the one below is for the action hit. If the top value is higher than the lower value, then the cell is turned to red, otherwise the cell is turned to green. And we have observed that after a million iterations, you would see the policy always converts to the optimal policy. And for some experiments, we have observed that our policy reached to the optimal policy, as you can see on the left, and our state value function was pretty close to the one that is known as optimal. For future, we would like to have handle special scenarios such as doubling down, soft split, and surrender. And I would also want to show that the agent is playing the game after learning the optimal policy. In conclusion, through this project, I've learned that reaching the optimality is challenging. Implementing an algorithm is okay, but reaching the optimality is always challenging. And thanks to my supervisor for their assistance, guidance, and feedback. And I will continue making efforts towards solving problems using reinforcement learning after getting some experience through this project. And these are the list of references that I have used for my presentation. And thank you very much for listening.